let's continue graphing equations using tables of values or t-charts. But what we're going to talk about in this video is specifically what to do if you have a fraction in your equation as a coefficient of x. So if you look at these examples right here, you can see x has a fraction as the coefficient. So there's a specific method to use here to make this easier than just using our regular 5 numbers, -2, -1, 0, 1, and 2. And that method is right here. We're going to choose multiples of the denominator for x if we have a fraction. And let's look at what that actually means. So for this first one, we have 1/2 x plus 3. And the fraction here is 1/2. The denominator is 2. So instead of using -2, -1, 0, 1, and 2 for x, we're going to use multiples of 2. -4, -2, 0, 2, and 4. One way you can think about getting these numbers is taking our normal set of numbers and just multiplying them all by the denominator. So if we multiply these numbers by 2, we get -4, -2, 0, 2, and 4. Or you can just think, what are the first two multiples of 2? That's 2 and 4, and use those. In any case, what we're going to do then is plug these numbers in to the middle column here. Now the benefit of using multiples of the denominator instead of just the normal numbers is that multiples of the denominator will be divisible by the denominator. And so what we'll get for our y values are whole numbers instead of weird fractions. If I try to put 1 in for x here, I'm going to get 1/2 plus 3, that's 3.5. It's a little harder to graph things when you have fractions. And so if you use multiples of the denominator, when you go to divide by that bottom number, you're going to get a whole number as your answer. So this first one, we've got 1/2 times -4 plus 3. Well, 1/2 times -4 is -2, and -2 plus 3 is 1. So that already you can see we're not getting fractions, we're getting whole numbers. 1/2 times -2 is -1, plus 3 is 2. 1/2 times 0 is 0, plus 3 is 3. 1/2 times 2 is 1, and 1 plus 3 is 4. And lastly, 1/2 times 2, or times 4 is 2, plus 3 is 5. Remember, to multiply by fractions, multiply your whole number by the top and divide by the bottom. And so now we can graph these points. -4, 1 is left 4, up 1. -2, 2. 0, 3. 2, 4. And 4, 5. And there's the line. So they're a little more spread out because our x numbers aren't 1 apart. Now they're 2 apart because that's what the denominator told us to do. But we still have a pattern for the y values, right? They're still following a pattern, and our points are still in a straight line. Let's try the next one. So again, it's going to make our t-charts here. And I would recommend for these fraction ones, definitely use that middle column because we're going to be doing more work on these. Fractions in general are sort of challenging. So always a good idea, if it's going to be a little harder, to use the middle column. Okay, now our denominator for this problem is 3. So we're going to take our normal numbers, -2, -1, 0, 1, and 2, and multiply them by 3. So the numbers we'll use for x here are -6, -3, 0, 3, and 6. So really just the first two multiples of 3, 3, and 6, and then also their negatives. So we'll put -6, -3, 0, 3, and 6 in here. So now we have to do -1/3 times -6. That's +2. 6 times 1 is 6, divided by 3 is 2. So +2 plus 4 is 6. -1/3 times -3 is +1, plus 4 is 5. -1/3 times 0 is 0, plus 4 is 4. -1/3 times 3 is -1, plus 4 is 3. And negative 1/3 times 6 is negative 2, plus 4 is 2. Again, you can see a pattern forming here on the y values. So let's graph these. Negative 6, 6, left 6, up 6. All right, negative 3, 5, 0, 4, 3, 3, and 6, 2. There we go. Nice and straight. We did it right. Let's move on. Example C. 3/4 x minus 5. Let's make the chart. xy, we're doing 3/4 x minus 5. So this is our first example where the numerator is not 1. It's okay. We're still going to base our x values on the denominator, which is 4. Don't know what just happened there. Start this one over. So 3/4 minus 5. Okay, so our denominator here is 4. Again, multiply those normal numbers, negative 2, negative 1, 0, 2, or 0, 1, and 2 by 4. We get negative 8, negative 4, 0, 4, and 8. Negative 8, negative 4, 0, 4, and 8. Because again, we're basing it on the denominator. So 3/4 times negative 8, right? We have to multiply negative 8 times 3 and divide by 4. Or you can divide by 4 first and then multiply by 3. Either way, we get negative 6. And negative 6 minus 5 is negative 11. Okay, 3/4 times negative 4 is going to be negative 3. Minus 5 is negative 8. 3/4 times 0 is 0. Minus 5 is negative 5. 3/4 times 4 is 3. Minus 5 is negative 2. And 3/4 times 8 is 6. Minus 5 is 1. All right, so let's graph these. Negative 8, negative 11. Left 8, down 11, which is off the graph. It's somewhere around here. Again, if you're off the graph, you don't have to use that point. You can just skip it and go to the next one. Negative 4, negative 8. 1, 2, 3, 4, 5. Is right here. 0 to negative 5. 4, negative 2. And 8, 1. Right there. All in a straight line, nice and straight. There you have it. 3/4 x minus 5. Let's move on. Example D. We're going to use our full chart. Negative 3 over 2x plus 2. All right. So again, let's fill this in. Okay, so for our x values, the denominator here is 2. Now I know there's a negative sign, and there was on the previous one, or no, there wasn't. There's a negative sign, but just ignore the negative sign for now. You'll deal with that when you actually do the operations in the middle. So denominator is 2, so we're going to use negative 4, negative 2, 0, 2, and 4, right? The multiples of 2. So let's plug those in here, negative 4, negative 2, 0, 2, and 4. So negative 3 over 2 times negative 4 is going to give us 6, right? 4 times 3 is 12, divided by 2 is 6. Negative times a negative is a positive, so positive 6 plus 2, that's 8. Negative 3 over 2 times negative 2, again, negative times the negative is a positive. 3 times 2 is 6, divided by 2 is 3. So 3 plus 2 is 5. Negative 3 over 2 times 0 is 0, plus 2 is 2. Negative 3 over 2 times 2, positive 2, is going to give us negative 6 divided by 2, which is negative 3, plus 2 is negative 1. And then negative 3 over 2 times 4, well, that's 4 times 3, which is 12, divided by 2 is 6. So negative 6 plus 2 is negative 4. If going through all that math verbally is too confusing to listen to, just write it out yourself or use a calculator. Try not to get confused by all of the operations here. Okay, so let's graph. Negative 4, 8, left 4, up 8. Negative 2, 5, 0, 2, 2, negative 1, and 4, negative 4. All in a nice straight line. Okay, looks good. Let's move on. Example E, 2 left. Okay, so our denominator here is 5. We've got negative 6 over 5 for the fraction. Negative 6 over 5 x plus 4. Okay? So let's fill in our framework here. So since the denominator is 5, we're going to use the multiples of 5, which are negative 10, negative 5, 0, 5, and 10, which are getting sort of large, but 10s and 5s luckily are pretty simple to do operations with. So we're going to put in negative 10 here, negative 5, 0, 5, and 10. So negative 6 over 5 times negative 10. Well, in this case, I think it might be easier to divide by 5 first. So we get 2 there times 6 is 12, positive 12, plus 4 is 16. Now that's going to be off the graph. I'm just going to do my best when I graph, and I'll probably skip that one. Okay, negative 6 over 5 times negative 5. Well, 5 divided by 5 is 1, times 6 is 6. 2 negatives make a positive 6, plus 4 is 10. Now that one's off the graph as well, but I'm going to be running out of points if I skip all of them, so we'll see what the rest are like. Negative 6 over 5 times 0 is 0, plus 4 is 4. This one gives us negative 6 plus 4, which is negative 2. And here we have negative 12 plus 4, which is negative 8. Okay, good. They're all following a pattern. They're going down by 6, so that is what we want. Let's graph these points. So negative 10, 16 is off the graph. I'm not even going to try. Negative 5, 10 is here, so that one I can do. 0, 4, 5, negative 2, and 10, negative 8 is also off the graph, but it's close enough. I feel comfortable. So these are pretty spread out. That's okay. Just do your best to make the line look nice. They are in a straight line, though, so we did it right. Okay, last one. Let's make the chart here. 2/5 x minus 1. So another denominator of 5. That's okay. We know what to do with that. I switched this style of fraction just to save space. I was tired of running into each other. So again, the denominator is 5, so our x values will follow that. Negative 10, negative 5, 0, 5, and 10. So let's plug those in here. My negative signs didn't take. Okay. So 2/5 times negative 10, that's going to give us negative 4. Minus 1 is negative 5. 2/5 times negative 5 is going to give us negative 2. Minus 1 is negative 3. 0 minus 1 is negative 1. 2/5 times 5 is 2. 2 minus 1 is 1. That should be a negative. Keeps making my negative sign disappear. There it goes. And then 2/5 times 10 minus 1, we get 4 minus 1, which is 3. So let's graph these. -10, -5. Now that's off the graph, and so will the last one be, but I'm going to go ahead and try because it's close enough. So 1, 2, 3, 4, 5, it's right here. -5, -3, 0, -1, 5, 1, and then 10, 3 is right here. These look like they're right in line. Draw the line, and there you have it. So important takeaway from these notes are to look for the denominator and then use the multiples of that number for the x values. And like I said on example 1, if you have trouble thinking of them, just take our original set of 5 and multiply by the denominator, and that will give you the new set.